Hello, my name is David Humphrey. I'm a research analyst with ARC Advisor Group based here in Munich. And I'm attending this week the Siemens Summit, AI with Purpose. This is a fantastic summit with about 500 guests, a lot of industry experts, a lot of people interested in the topic. And we've come to exchange ideas and to learn more about how AI is affecting industry. I'm happy to have as my guest Boris Scharinger. Boris, you're AI strategist for Siemens Digital Industries. You're
Yes.
the expert on the industrial side.
Yes.
You and I have both been in the industry for a long time, and we're used to the industry's reluctance to accept commercial off-the-shelf technologies. That's all gone out the window with Industry 4.0. We're modernizing nowadays. That's very clear. But I'm intrigued by your use of the term industrial grade AI. Once again, you're putting in a qualifier in front of AI, saying that there's a special need or special things we need to do with AI to make it suitable for our industries. Can you tell us more about industrial grade AI?
Yeah, I can certainly, and thanks for being here and having me, David. Industrial grade AI, we coined the term to kind of shout out a message into the ecosystem. We really must get together and work hard to mature AI further, right? My favorite analogy is, if AI would be reliable and robust, we would all be driven in autonomous cars, right? But we are not, at least me. I have been coming to this event just normally without an autonomous car. And why is that? Because AI needs to mature. We have AI coming from the consumer space, from the social media space, and so on. 80%, 90% accuracy, all of that is acceptable in most of their use cases. But in industry, specifically on a shop floor, you need to have the 5 nines, right? The 99.999%. You cannot afford regular failures or hallucinating language models. And for that reason, we have quite a way to go to mature AI. And industrial grade AI serves as a term to purposes. Hey, ecosystem, we need to work together. But also, Siemens stands in for a quality ambition. We would like to drive that. We see it as our role to help the ecosystem making AI industrial grade.
For now, it seems like we're talking a lot about generative AI, but that's only one flavor of AI. Can you put that in the spectrum to help us understand AI from here to here? And can you tell us why suddenly we're talking about generative AI?
Of course. So first of all, AI in industry is not super new. We have machine vision, right, for example, with amazing use cases also for quite a while. And many of those use cases work also with the degree of robustness and reliability. But we have a lot of challenges also in the space of, time series, right? Machine learning for time series, anomaly detection. Take the vibration patterns of a pump in cavity, of a broken bearing in a drivetrain, right? And we have done a lot of work to solve these types of use cases. And one of our major challenges was that if we have solved it for one machine, it wasn't generalizing well enough that we could take it and apply it to the next machine. So we had to start the next project and, right? Now, having said that, I'd like to add actually that AI also plays a major role in the space of product design. Right, optimizing, simulating product designs, not just looking at the shop floor, but earlier already when product designs and work item designs are shaped. So these are important areas. And then certainly with generative AI, we see an additional momentum in the industry, because in the past, AI really used us to automate simple tasks, right, repetitive and simple tasks. And the large models have added a new quality, which is I can automate repetitive, complex tasks, if that makes sense. Yeah, the lawyer that has to draft a contract, yeah, the software developer who has to write code, right? We can support those types of professions with the support of generative AI, and it helps them. Maybe it makes them just 15% more productive. Doesn't replace them, but it supports them wherever something is repetitive.
Can you tell us more details behind generative AI? There's some terms that I had to look up in the past year. A year ago, I'd never heard of a large language model, and now we're talking about foundation models as well.
Yeah.
Can you explain those and tell us what role they play, and also where they physically sit? Is it something you put in a local PC on a machine? Is it something in the cloud?
Yeah, that's a good question, and maybe also a journey that we have in front of us. Let's start with large language models. Right now, the first important definition is they work on language very well, and basically tech players have almost scraped the internet, you know, the Wikipedia pages of this world and so many web sites to train those large language models, and now that's how they work. They work fantastically well with language. And language includes, by the way, programming languages, which is interesting for software developers. But it is a probabilistic model on what is the most likely word that comes next, right? That's the character of what they do. Yet they have unfolded a popularity and power because even our kids are kind of trying to do their homework now with the use of very, very easily accessible platforms and web pages offering access to those large language models. Taking that term aside for a minute, you mentioned foundation models. And I'd like to put a business model perspective on foundation models. Business model perspective in a sense that foundation models are models that are created by one party with tremendous effort. So hundreds and thousands of other parties can consume that model and build their use cases on top of it with incremental project efforts. Right? David, in industry, specifically, we have the problem that every AI use case that we try to implement is a project. And then if you train it on one machine and you try it on a very similar but not equal machine next door, you almost restart half of the project. So the project effort, specifically in the industrial space, in comparison to the value pool that you address, are really high. That's why AI adoption in industry is fairly slow, up to now. A foundation model carries the promise that one party does a very, very well generalizing huge model, and then with almost no decentral project effort, you can tackle your local value pool. And that changes the commercial mechanics. And that's why there is the promise, the implicit promise, that foundation models will bring a lot of momentum into the use of AI in industry. However, maybe not language, but maybe we look into large robotics models or large machine vision models in the future. Again, all carrying the promise that they can be deployed with almost zero-shot learning and make a difference to the value chain and the value pools of our customers.
Fascinating stuff.
Indeed.
Very, very theoretical, very, very interesting. Let's see if we can drag it down to the practical side. Remaining with generative AI, what are the first practical applications that are using it or that will be using it in the next few years? Where's it going to make a difference at the very beginning?
In industry, right? Well, first of all, we all know that automation skills are scarce, right? People who really know PLCs and PLC code and so on, that is increasingly a challenge. And I hear many of our customers telling us that they could actually, from an order entry perspective, they could grow a lot faster with automation projects and engineering projects if they would have the workforce to do so. And that's why certainly one of the first applications is that we take the powers of generative AI specifically for tasks like software engineering and apply it to creating and generating code to automate. That can be graph code that runs on a PLC, that can be classical ST code, structured text, to simply become faster. You know, you have a certain workforce, but that workforce has a higher output. The engineers, the automation engineers have a higher output, and that's why our industrial copilot technology, the industrial copilot for engineering, is so popular and sees so much demand.
Moving away from generative AI that really hit our industry just in the past year. I mean, we didn't expect this this huge change. Just AI in general goes hand in hand with data, And I like to say that our industry discovered data 13 years ago. That's when Industry 4.0 was that nudge from the German government telling German industry to get going and to modernize. One thing that's always interests me is the amount of data. If I look at AI in the commercial world, there's consumer data, hundreds of millions of consumers and their buying habits, all these data points that are just waiting to be analyzed by tools that help us, that help show us the real picture. In industry, though, if I think of a typical machine that has a few dozen data points, a process might have on the order of 100 to 1,000, a chemical plant, a typical control system might have 6,000 to 8,000 I/O points. I'll call those data points so the data scientists understand what I'm talking about. Add on a few things from MES and from the ERP system for order processing, and we're still many orders of magnitude lower than the commercial world. So does it still make sense to draw on these AI tools to analyze the data we have to get some value out of it, or can we just look at some printouts and make our own decisions?
Well, first of all, there is no AI if you don't fuel it with data, right? And if we approach the value promise of foundation models, in the language area, they are so strong because they have so much input from the internet, right? And industry must get together and find ways to add the context, right? Add the, do the semantical homework, and then find ways of creating use case specific data pools and cooperations, or work with other means of trust, as an example, federated learning. So we can, it's the fuel, data is the fuel for superior AI, for advanced AI, that really makes a difference. So we need to go there, and there are some specific challenges in handling industrial data. First of all, of course, concerns of losing IP and trade secrets, and this is why companies find it difficult to share. And then also sparse data, right? You have 1 million records, but out of the 1 million records, only 2 are relevant to the particular use case, because 2 represent the failure of a machine, right? We have companies that are so great that out of 10,000 parts they produce, they have 2 misses. Yeah. But these are the records that you want to catch to train your AI. So how do you deal with that? And that is part of the journey ahead of us, right? This is the reason why we are meeting here, why we are discussing AI and industrial AI, and why a third of this conference was actually touching AI, but it was really about the data and the data challenge.
I noticed that, yeah.
Yes.
I saw an interesting presentation today on talent, on acquiring talent for AI. And in one chart, Siemens topped industry peers in hiring people with advanced skills for AI. I found that very interesting. All companies are grasping for the talent, but Siemens has been the most active amongst its peers. In terms of products and solutions, what can we expect from Siemens? If Siemens is the leader in that sense, what practical products that are AI products or products in which AI is being integrated are coming out now? And what does the roadmap look like in the next couple of years?
So let me kind of try to explain our portfolio and the role that AI plays in our portfolio first, right? We have one big headline that is smart UIs. What does this mean? Large language models fundamentally change the way how humans can interact with software and systems. Yeah, we can use natural language, where years ago we just had to use these kind of crappy UI masks, right? To get data out and get data in. Now we can use natural language. That's a big change. So one thing is that any piece of software, any system that we as Siemens provide will at a certain point in time be able to work with natural language. And that's a general theme that is kind of going through it. It's the river that flows through our portfolio. The second category of tools that we work heavily on the AI side is anything design space exploration, anything simulation, anything digital twin. And it's very clear, the more we simulate and the faster we simulate, the better products we can build, the better production lines, the more efficient and resource efficient production lines and products we can build. right? So the only constraint in building better products is the ability to simulate them in time, and AI has a tremendous contribution to speed up those processes, those simulation processes for digital twins. So that's design space exploration is one of the other portfolio categories, if you will. And then we have what we call the AI-enabled operations of a shop floor. And this is many, many different products that help our customers to build their own AI use cases. Let me give you an example. So our industrial IPC with an industrial NVIDIA graphic card in it, it's just a platform, and you can get that platform, of course, to build whatever you like to build. And we have software tools, we have tools on the deployment management, model monitor level, we have machine vision elements of that. All those tools that our customers, system integrators choose to provide their specific use cases, which we don't know, to their particular customers. And all of that has to be industrial grade again, right? You need to build GPUs in a way that they survive the harsh conditions of a shop floor. You have to build, for example, our AI module, TMMPU. It is fanless, right? So the way it cools has been intelligently designed to be able to use it fanless, because then it can survive harsher production conditions, a lot harsher than the usual stuff, if I may say that. Mm-hmm. And the second thing, industrial grade, is also that we can support, by the way, our customers worldwide with these types of products. If you build the same production line in Brazil as you do here in Germany, you'd like to get, spare part warranty, field force services, and all that is part of an industrial grade offering that customers can really use when they want to leverage the powers of AI in their specific environment. So that's our portfolio. In all of these aspects of the portfolio, of course, we have R&D roadmaps that would now step by step include a couple of more pieces, for example, from the powers of large language models to generate, to prepare stuff, to model stuff, to operate MLOps, right? To operate solutions on the shop floor.
Fascinating stuff. When new technologies come out like this, or when we're in the big phase of where there's a lot of activity, we think that AI is going to accompany us forever. But I like to think of a time when AI just goes away, because it's already in every product, that we no longer need to talk about it. It's simply there, it's integrated, it's folded in. Is that realistic? And in what sort of time frame do you think that we're going to not have a need to come together to talk about this new stuff, because it's already everywhere, it's part of everyday life?
At a certain point in time, I think the hype goes a bit, and then the daily work continues to stay there. Mm-hmm. Maybe the experts will continue to talk a lot about it, maybe not so much the public. Let's see. I am still amazed in the technology leapfrogs that we see these days, right? It's pretty amazing. It's so amazing, I heard from a partner of ours, that if you apply at a conference with a research paper, that by the time that conference actually runs, the research paper might be outdated. I still believe that the challenge to master the quality of AI that challenge will stay, and we will be pretty busy with managing the quality of AI, because as much as the capabilities of AI advance, we need to be behind it, staying on top and making sure that the quality promise gets delivered and not compromised by the technology leapfrogs that we see.
On that note, I want to thank you for a really interesting interview and an excellently organized and very informative summit here in Munich. Thanks, Boris.
Thanks for coming, and thanks for having me here. Thank you, David.
And to our listeners, thanks for tuning in, and we look forward to seeing you in our next webinar. Thank you.